Okay, so now we're going to look at Unit 4, Lesson 9, using trigonometric ratios to find angles. All right, so 9.1, the warm-up. A triangle with side lengths 3, 4, and 5 is a right triangle by the converse of the Pythagorean theorem. What is the measures of the acute angles? Okay, so quick review, because I don't know if we ever really stated that this was a converse or what a converse is. So we know that Pythagorean theorem is a squared plus b squared equals c squared. And we proved that by having a right triangle. And for example, I'll use these measurements. If we know that this is 3 and 4, then we do 3 squared plus 4 squared equals c squared. And we solve this out. Take the square root of 25. So we got this side. So that's how you would have just proven with the Pythagorean theorem. The converse of it is we give you three sides of a triangle. So let's say they give you, let's say 7, 12, and 15. Prove that that's a right triangle, or disprove it's a right triangle. So we know the longest side is always C. So we would write this out. 7 squared is 49. 12 squared is 144. 15 squared is 225. Well, 49 plus 144 is 193. So this does not equal each other. So these three sides cannot be a right triangle. Okay, so that's proving the converse. Okay, this is proving the converse of the Pythagorean theorem. So I just wanted to go over that vocabulary so you understand what this question's asking you. So now what it's saying, though, is if this is my triangle, and this is 3, this is 4, and this is 5, because I know opposite my right angle is my longest, my hypotenuse. So find the measures of the acute angles. So we want to find the measure here. We learned earlier. We can call this theta. And we can call this beta. And it's wanting us to find those. Well, I'm going to erase what I did so I have more room. To find theta, what we've talked about so far is TOA. And all we've looked at, if you understand this question, all we've looked at so far on trigonometry ratios, all we've looked at so far is how to find side lengths. We haven't yet really found angles yet. An angle is always given to us. So let's think about what this is doing. I am going to use theta. I'm going to look at theta, and I'm going to use sine. Excuse me. So sine is, I want the opposite side. So I want sine of theta is my opposite over my hypotenuse. Now, we haven't learned yet, how do I, if I gave you this problem, then we know how to isolate x, right? Divide by both sides, and x is 2. But we haven't learned, how do I get rid of sine? So that's what we're going to learn here in a second. So think about that. Somehow I've got to get sine to the other side, but we don't know yet. So theta would be sine of theta equals 4 over 5. Or I could look at beta. Beta here, let's do another one. Let's look at cosine. Then I could say cosine of theta is also 4 over 5, which is what we learned in the previous lesson. Sine of the same angle, cosine of the same angle, they're going to be equal to each other. Oops, not the opposite angle. Beta, my fault. Okay, but we don't know how to isolate sine and cosine yet. So let's look at 9.2. And let's just set this up. So we're going to let this angle right here be our theta. So if we're having this angle, we have our opposite side, and we have our hypotenuse. Okay, knowing that, then we know we have sine, opposite over hypotenuse. So sine theta is equal to opposite, which is 9 over 10. But somehow I'm needing this sine to get moved to the other side. That's where this new phrase will come in, and we call it arc sine. Okay, arc sine is also, what that means is opposite. So like adding and subtracting are your opposites. Multiplying and dividing are your opposites. Squaring and square root are your opposites, your inverse operations. So sine and arc sine are your inverse operations. Okay, now sometimes a calculator will actually say arc sine. Sometimes the calculator will have to the -1 power. Okay, so the calculator that I put as a resource on your weekly checklist will actually have it listed this way, and I'll show you that one here in just a minute. But to divide by sine, to do the opposite, it's called arc sine. So I'm going to leave theta on this side, and I'm going to say arc sine of 9 over 10. And we just plug that straight into our calculator. So I do have the calculator pulled up. So if you look, you have, oops, I can't write on this one, main, ABC, or function. You want to click on function, and then you notice that we have sine of -1. So you want to click sine of -1, and then we're going to click back to main, 9 divided by 10. Enter, and I get a measurement of 64 degrees. Okay, so theta is 64 degrees, which means then the opposite side is going to be 90 minus 64. So my other angle is going to be 26 degrees. Now it does say find all the missing sides and angles, so we still have this side we need to find. You can do it by sine, cosine, theta. You can do it by the Pythagorean theorem. I'm going to go and do Pythagorean theorem so we get used to using that one again. So we're looking for a side, so I want to do hypotenuse 10 squared minus side squared equals my missing side. So 10 squared is 100 minus 81, so give me that side. 100 minus 81, oopsie, we get 19. Take the square root of 19, and we get square root 19 is the precise measurement, but decimal we get 4.3. So this side's going to be 4.3. All right, go ahead and pause the video and try to do the next two on your own, and then come back and check your answers. Okay, I went ahead and had to erase this, so hopefully you had that part down. If not, rewind the video, get that part down. Now I'm going to look at the second one, and hopefully again that you've tried these on your own. Alright, I'm going to look at finding and calling this angle theta. It doesn't matter if you found angle D as theta. Everything should still work out. You should still get the same answers. There's so many different ways that you can work these problems. Alright, so I'm going to look at theta here, which means I have opposite over hypotenuse again. So sine theta is going to be opposite over hypotenuse. Again, I need to move this to the other side, inverse operation. So I leave theta where it is. Arc sine, or sine to the -1, of 4/7. So I get that my theta is equal to, if you plug that in the calculator, is 35 degrees. And with measurements, I don't know why that's not going away. With measurements, just use whole numbers. They're easier to work with. So we get 35 degrees. Oh my gosh. Here. Okay. So if we know this is 35 degrees, then we know this other angle is going to be 55 because we're doing 90 minus 35. So we get 55 here. All right, we still need to find this opposite side. So again, I'll solve it this way with using trig functions. So let's say we want to use, I want to keep using 35. I like to stay with the same angle so I don't get confused what I'm working with or where I'm at. So if I know that this is 35, then I'm looking for this adjacent side. So adjacent, remember, is cosine. So I'm going to do cosine of 35 degrees is equal to adjacent, which I don't know yet, over my hypotenuse. So multiply both sides by 7. And so type that in your calculator. Cosine 35. Enter. So I get 5.73. So this side will be, x equals 5 point, let's do 5.7 units. Again, if you use Pythagorean theorem, same thing, you're going to have hypotenuse minus your side, and you're going to try to find your third side. So this is 49 minus 16, which is x squared. 49 minus 16 is going to give us 33. Square root both sides there. And then, let's see, square root of 33 is still the exact same thing. So 5.7, which I was kind of double checking us. So I'm just trying to show you that you can pick any way you want to. There's so many different ways out there. Just find a comfortable kind of rotation through a triangle that you like to use and stick with that. I wouldn't try to do something different every single triangle you look at. Okay. So I'm going to do a quick, just make sure we're understanding. I'm going to erase this. So again, pause it at this moment if you haven't wrote all this down. Let's think about what we've just talked about. So the inverse of sine is arc sine or sine -1, depending on your calculator and how to type that in. Remember, this is just the inverse operations, which means cosine, the inverse of cosine then would be arc cosine or cosine to the -1 power. And then same thing with tangent. I just want to make sure y'all understand that all of these are the same. That's what this arc, tangent, arc, sine, all that. It's just meaning opposite. It's how you solve equations. So that's tangent to the -1 power. All right, so just, you might put that in your notes somewhere so you understand this is just the inverse operations. It's the same thing how adding and subtracting go together. Multiplying and dividing. Squaring a number and square root that number. Okay? This is the same thing as that. So don't get caught up in the terminology. It's just opposites. All right, let's look at the last one. Here. Okay, the last one. So let's call this theta. Again, if you call j theta, perfectly fine. I'm going to look at this, and I don't have my hypotenuse this time, so I can, oops, y'all didn't tell me I had that wrong this whole time. So I don't have my hypothesis this time, so the only one with the given information that we can use is this one. So I have tangent theta equals opposite over adjacent. So opposite, I need this to move to this side, so I'm going to leave my theta where it's at. Arc tangent, or tangent to the negative 1 power, which this just means inverse. So the inverse of tangent of 6 over 5. Type that straight into your calculator. And again, just round to the nearest whole number, so we get 50 degrees. Which means 90 minus 50, hopefully I don't need to write this out for you all, but I will, is 40 degrees. And then theta is 50 degrees. All right, I'm going to use Pythagorean theorem. I just find that's the easiest to find that third side. And since we are looking at that third side, we are going to do 5 squared plus 6 squared to give us c squared. 5 squared, 25. 36 c squared, so 25 plus 36 is going to give us 61, and square root both sides, so c is, and I haven't figured this one, so hold on, c is 7.8 units. So even if you didn't work it the same way I worked them every single time, you should still get the same values. So if you did miss one there, kind of look back. If you have questions, take a picture of it, shoot it to me, do something to see where you messed up at. Okay? All right. So let's move on to this next one. And this is not my favorite lesson right on this one. It's not terrible. Sometimes it just gets a little bit confusing, I feel like. Until you put actual values to it. So a good rule of thumb for a safe angle to use when leaning a ladder is the angle formed by your body when you stand on the ground and hold your arms out parallel to the ground. So what are the angles of the triangle formed by your body and your ladder? So if you look at this picture, make it a bright, let's see, we're forming this triangle right here with our ladder. And then what they're saying is our arms are parallel to the ground, and then our body's going to be parallel to the house. So we're sharing this angle, okay? So, again, going back to what we remember about parallel lines, if this line's parallel to this one, and this is cut by a transversal, then this angle is congruent to this angle. This is a 90-degree angle. This is a 90-degree angle. Which means if two angles are the same, then we have similar triangles. Because then this one now is going to be congruent to this one. So they form similar triangles. And now knowing they form similar triangles, then you can just kind of, this is going to be equal to 90. So you can just, we don't have numbers, we don't have anything to use. You can just kind of glance and just, I use 75 and 15. I said this angle is 75 degrees, which means this angle would have to be 15 degrees. So what you want to make sure is that you came up or you have complementary angles. But everybody's could be different, just as long as they're complementary. Which I think is number 2 as well. What are the angles in the triangle formed? So actually, yeah. So if you put 25 or 75 and 15, 65 and 25 degrees, anything like that, just to make sure you have that combination. And that's your reasoning as well. All right, and then this part is where we can kind of start seeing how you would solve this. So let's draw this out. You have a 30-foot long ladder. So here's my ladder leaning against the wall. It's 13 feet. and you need to climb to a 12-foot tall roof. So my height is going to be 12 feet. So finish our triangle. We know we have a right angle here. If you put the ladder at the top of the wall, what angle is formed? So we're looking for this angle here. So again, we have opposite. We have hypotenuse. So if you look back at your notes, opposite of over hypotenuse is going to be our sine. So sine theta is opposite over hypotenuse. The opposite of my sine is arc sine of 12 over 13. Okay, so once we type that in the calculator, you're going to find out that your angle is 67 degrees. So we know this is 67 degrees. Okay, is it down here now? Is it possible to adjust the ladder to a safe angle? And if so, give someone instructions to do so. If not, explain why or why not. So, is it possible to get 67 degrees here? Well, to find that out, we need to know how far away does it need to be from the wall. And so we can do, this is a side hypotenuse, so I'm going to do Pythagorean theorem. So I know my hypotenuse. I'm going to subtract it with the side that's given to us, and that's going to give us our third side. So 13 squared is 169. 12 squared is 144 equals x squared. So subtract these two, and we get 25. Square root both sides. We get a nice pretty number this time. So we know that we have to be 5 feet from that wall. As long as we're 5 feet from this wall, then having a 12-foot roof with a 13-foot ladder, this is going to give us our safest distance. Okay, so here's your summary if you want to look over that again. Just kind of sum up the week. This is your video that you should be doing on Wednesday. So your cool down for this one, I will post on Thursday. You also have a Delta Math assignment that I've listed it due for Friday, but you can do that at any time. Make sure you have to show your work. Okay, I've put a spot down on that checklist sheet so you can show all your work. If you want to work it on a paper at your house and take a picture of it and upload it, that's perfectly fine. Just make sure you show your work so you can get your full credit for that. All right, again, if you have any questions, I'll be live. I'll have a live session Tuesday and Thursday. And then I'm looking at Friday too if we need to do that. Or send me emails anytime in between there. All right, thank you.